All right, everybody. Let's talk about this stuff. So we will have a test on Friday. So after I get through this, then we'll have a review, and then that you can work on. And then Thursday will also be a review, and then Friday we'll do the test. We won't have a quiz on this chapter because it's short. Okay. Problem number 1. Hey, problem number 1. Decide if the following deal with means or proportion, so an average or proportion. So A, what percent of the class has applied to college? It's probably a proportion. Okay, we can take that pretty easily. The average application cost, well, that should be easy. Then they said the word average, so that's got to be means. The average GPA, again, average, we're talking means. How many colleges are you applying to? What do you think?
A portion out of all the colleges in the world.
Yeah, I think you could argue it multiple ways. I think that's kind of a bad one. If I give you a test question on that, it'll be one of those, let's do it as a class. So I think you can argue a point both ways for letter D. It could be a means, but it also could be proportions of how you phrase it. What percent of the class is looking to stay in state? That would be a proportion as well. What percent of the class plans on joining the military? Also proportion. The average scholarship money received by the class, that would be a means. Okay? I thought that was like, number 1 there was kind of just this random, here we're just going to throw this in at you and see. So, number 2. So again, we're continuing to use our calculators. The calculator you'll be able to use on the entire test. That NCDF, the normal mean distribution, works nicely. So problem letter A, it says it's believed 55% of a hospital's patients enjoy the food provided for them. A random sample of 20 pediatric patients is selected. What is the probability that fewer than 50% enjoy the hospital food? Okay. So this is letter A. So this is going to be the NCDF on the calculator. Remember, it's going to be second bars. In the first thing, we're looking for, they said, what is the probability that fewer than 50%? So fewer than 50% mean you're talking about 20, or you're talking about 20 patients selected. I don't know, you can make that 0, you can make it like negative 100 or something like that. And then fewer than 50%, so you're talking about 0.5 or 0.50. And then they say that, they claim that your average is 55%, so we're going to have 0.55 right there. And then the last one is going to be, you have your success, which is this, your Q, which is this. So then under the radical, you're going to have 0.55 times 0.45 all over 20. So it's going to be the square root of all that. And again, careful on your calculator how you plug that in. I was helping a couple people yesterday, and I noticed that sometimes on the calculator, if you have the square root, it might give you this. So if you were at 0.55 times 0.45 and then close the parentheses, it might do this, which means it's only taking the square root of the numerator. Make sure if you went with this kind of situation, you add a second set of parentheses. You do that, that should extend that all the way. Okay? If you're still continuing to have problems with that, do this off to the side. Do the math, figure out what that answer is, whatever that answer comes to, divide by 20, whatever that answer is, then plug it underneath your radical, your decimal radical. Does that make sense? So just be cautious because some of your calculators were showing the square root like this. It didn't show it, this line continuing over it. So I think the calculator sometimes is going to give you an incorrect answer, though you are doing the steps correctly. So just be very cautious. An extra set of parentheses might not hurt in this case? I didn't get an answer for this. Any of you got an answer?
32.6%.
How much?
32.6%.
32.6%. Okay. So 32.6%. As this number increases, this is going to lower down. Okay, because you're talking about a smaller and smaller and smaller. Excuse me, smaller and smaller and smaller cross-section area of the area underneath the curve. Sometimes you might want to think of this as it's taking a slice. Okay? Now, if y'all are like me, I don't know if you ever get that warm French bread from the King Supers. It comes out at 4 o'clock, guaranteed fresh every day for $1 or $1.50 or whatever. I don't know about y'all, but that nice warm bread, nice thick cut of it with the butter that's melting into it. You guys know what I'm talking about? And I like when I cut it, but I don't like the ramifications when I cut it. That's when my wife comes in going, "Who ate half a loaf already?" That's for dinner. It should be really thin slices. Warm French bread, thin slices. I'm sorry, I can't do it. I make enough money, and in a conversation with my wife, I make enough money we can buy 2 loaves. It's okay. Yeah, but it's not good for you. Neither is cigarettes, and you'll go buying those. So, my wife will always tell me, "Oh, it's not good for you." It's like, well, if it's not good for me, why are you buying it? It's not good for me. I buy a pack of smokes too. I saw it silly on Jimmy Kimmel the other day. I don't know why this came up. I won't bring it up. I won't pull it up yet, but I thought it was funny because he's talking about vaccinations. And he said, he brings up, he goes through a couple funny things. Obviously, vaccinations are, a topic that people are like, "Oh, it causes autism." No, it doesn't. And the study that showed that it led to autism never showed that it led to autism. And that doctor who made that study is discredited just because Jenny McCarthy now has her clothes on and is not posing for Playboy magazine doesn't mean that she's a doctor. But she's a big advocate for don't immunize your kids. It's gonna make them have this or that. But Jimmy Kimmel goes on this whole spiel that says, obviously if you know more than a doctor, then why would you even go to a doctor to get medical treatment? Because you know more. And then it spiels out a little bit more. Thank you. Okay. Good. Perfect. Do I have this person? I don't have that person. Oh, that's period 3. We're in period 2.
Okay.
So you want me to leave it? I can leave it for Mr. T.
Yeah, do you mind?
No, that's easy.
Okay, thank you.
So then, he goes on to the whole thing saying, pretty much every doctor in the United States is gonna, be a proponent of vaccinations. And yes, I understand you can find a random arbitrary person that's a doctor that says it's bad for you. But most doctors are gonna claim that it's good. And he said, well, if you don't know what a doctor's talking about, then you might as well have kids smoke because it's about the only people that'll tell you that smoking's bad for your health. That's also doctors. So I just kind of thought it was funny. I'm sorry, I shouldn't have gone on a political agenda with you. Letter B. I can imagine you guys when you're absent, you're watching the videos at home, going, "What the hell is he talking about again?" Let's see. Letter B. A high school is concerned about eligibility of its athletes. It examines a random sample of 75 athletes to see what proportion have a D or an F in at least one class. There are 500 athletes in the school. The athletic director, The athletic director believes that 35% have at least a D or an F. So let's see. The success here is they think that 35% have a D or F. The non-success of this would be, 0.65, is that right? Okay, we're talking about 75 people that we're looking at. How should we do it? Any ideas?
Would you do 1/75? No. Well, for the first sentence.
Well, I know at the end of this, let's see, I'm thinking it's NCDF. Let's figure out what those are. Let's see, the average, they feel that the mean, the athletic director believes 35% have the DRF, so that's, wait. Oh, okay. Yeah, that's what I was trying to think. So that, like, if we were to do this, it would be this over 75. Why is it not going to work? Hang on. What's different between letter A and letter B other than it's a different story problem? That it doesn't work? Explain why you cannot use the methods in this section for the following situation. Oh, really? That happened? Okay, what? Hang on, let's go back to this one. So, wait a minute. What are the three assumptions again? I forget. Is it random? And then does it say it's random? Yeah. So letter A, random works. Why does it say that? Because it says we select a random sample. Addie, for a little. Okay. So it is a random sample on letter A. Letter B. Why is Alex talking again? Are you not tired again? You are talking. Letter B on this one. This was the number P times N and Q times N, and both of those had to be above 10. And we're talking about how many patients? So Pn is 0.55 times 20, which is a greater number than 10, but 0.45 times 20 is less than 10. So because that's less than 10, that means we can't even do the problem. So this doesn't even work. Oh, shoot. That's why we have those tests in place. I would have saved all kinds of time. Doggone it. It's Alex's fault. Sorry, I got to blame you still. Okay, good. All right, so let's see this other one. Letter B. Let's make sure that it all works. Is it random? It says it examines a random sample of 75 athletes. Well, sounds random. And then if we go this times the 75 and this times the 75, that's greater than 10 and that's greater than 10. So that passes that test. What's the last test?
To do the standard errors.
Standard error.
Or independence.
We want to check for independence. And independence has to be what percent? Less than what percent? If this is less than 10% of our population, then it's going to pass. Okay, so it says that we have a high school of how many athletes? 500, and we're going to test how many? 75. What's 10% of 500? 50. So we have to test less than 50 kids in order for to show independence. If we're going to test 75 kids, we don't have independence, so this doesn't pass our test. So we technically shouldn't use it. So, thank you for reading the directions. I wish I had learned how to read directions, but I'm that guy at Christmas that I try and build the toys without reading directions. I'm going, how do I have extra parts? And then my kids are like, it doesn't look like that. Sorry, some of you might be that same person later in life, which is okay. I've made it this far. Letter C, airline claims 85% of its flights are on time early. Random sample of 15 planes selected was probability that more than 80% will be on time. So C, random, it says random, yes. It says it. And then we have the probability of on time and the probability of it not on time times what? Huh? Toilet? 12? No, 12 is not even a number to consider in this problem, but good try. 15. So 15 and 85% of 15 and 15% of 15. Well, that's definitely less than 10. And this might be greater than 10. So right there, because this takes place, we can't use it because the probability of it happening and the probability of it not happening are going to be less than 10. So that goes for the, what is it called? That goes to make sure that it's a normal distribution. They both have to be the same, or they have to be both bigger than 10 in order for it to be a normal distribution. Okay. Number three. Number three, in March 2012, Consumer Reports estimated 59% of American households have Wi-Fi in their house. See if your neighborhood is any different. You randomly select 100 households in your neighborhood to ask if they have Wi-Fi. Do the three assumptions apply? Is it random?
Yeah.
This is tough. We're comparing the entire United States, right? You randomly select 100, but of what? Your neighborhood. So you're trying to compare your neighborhood, a random sample of your neighborhood, to the whole United States. Just because it said it's random, is it random? No, you're taking a specific portion. So I don't know where you guys live, somewhere around here, I imagine. But if you were to block off, between Bellevue and some other major road and Yosemite and some other major road, that might be like your neighborhood. And so if you were doing a test of your neighborhood and you randomly selected your neighbors, then that could be random. But then you have the United States as a whole, and then you're going to randomly select just from your hand-picked neighborhood. Even though it says it was randomly selected of that, it's not going to fall under the random category, I don't think. Okay? I think the other test would work. The independence, you're talking about 100 homes. 100 homes is definitely far less than 10% of the entire United States population of homes. So that would work. And if it's normal, 0.59 times all the homes in America and 0.41 times all the homes in America is definitely going to be both values bigger than 10. So that would work, but I don't know if the random is going to work because it'd be like us saying, okay, let's pick a random selection of students, seniors at Cherry Creek High School and apply them to the nationwide. Now, I think it is because it's a selected region. I think so. Like if we were to let's make up a silly Obama feels that 35% of high school seniors in America have never seen snow. So we're talking about all high schools in America, or seniors of high school in America haven't seen snow. And then we were to come to Cherry Creek High School and say, let's do a random sample so it would work. Obviously, if you haven't seen snow, you haven't been paying attention. But if you were in Tempe, Arizona, that might be a higher percentage because Tempe, Arizona doesn't snow. Which I know is strange, but still, it is what it is. So I think that's why we can consider it not being random, because you're then in a more select area. As far as the Wi-Fi problem, I would say the homes in this area as a whole would have a higher portion of Wi-Fi in their homes than a very non-affluent, poor migrant worker area. Would that make sense? And I think that's where the randomness needs to take place, is just because you're taking a random sample, if you're trying to apply to an entire whole nation, now it'd be different if we said, okay, the seniors at Cherry Creek High School, we want to compare all the students at Cherry Creek High School, all the seniors at Cherry Creek High School. We feel that, and then this was like the parking problem we did yesterday, said that a certain percent, you know, the Principal Silva feels a certain percent of high school seniors have parked illegally on campus. Being that we're talking about just this group here on this campus, and then we can randomly select, that would be random. But if we were to make a judgment call saying, let's talk about all high school seniors in America, there's definitely places where students might not have driven, especially if you live in a city. A lot of times if you actually live in a city and your school is in a city, you are not taking a car. You know, if you live, you know, I don't know if you've ever been to New York City, but it costs you probably as much to park your car in New York City as it would to have an apartment in New York City. So unless you're living in your car, that might not be where you want to go. So I think that's where we need to think about the randomness. Okay? Where am I at now? Oh. Am I still on the Wi-Fi problem? Okay, what is the probability that more than 60 houses have Wi-Fi? And again, I don't think it can work because I don't think it's going to fall under. I mean, we can do all the tests for it, but it doesn't mean it necessarily has to be random. And I think that falls under C as well. And then D, you find that 80 houses in your neighborhood have Wi-Fi. What is the likelihood that 100 or more houses have it? If you truly went and did this problem and you've realized, okay, I don't care about the randomness. If you did this, 90 out of 100 of the people surveyed, if you find this rather than 100%, I think you're going to be surprised. And then if you made this like 1,000, saying more than 1,000 houses, if you did the 0.59 and then you did this.
Why is it 90?
I'm going to show you why I did 90 here in a second. Okay, so what would be more likely to happen? 100 out of 100 or 90 out of 100? Okay, so this will be an easier one for us to test. So this is more likely to happen than have 100% out of 100%. So if we do this, if we do truly do this math, you're going to come up with this for an answer, which is so 100% would even be less than that. So as far as our math goes, now we obviously know that we can't do the math because it's kind of hard to say, hey, we're trying to attribute this to the entire nation, but we're talking about just our neighborhood here. That's pretty unlikely to happen as far as that goes. Letter D, an opinion poll asks a sample of 500 high school students whether they favor the first semester before winter break, school would start earlier in August, but students would be done by the end of May. Suppose that in fact 32% of students prefer to end the semester before winter break. Okay, so is it random? One question I have here, we're saying a sample of 500 high school students, but from where? One high school, all high schools, Colorado high schools, I don't know. So it could be random if we're, let's assume we're assuming all high schools. If we were to do our normal distribution, we'd have to think about, if we were talking about all high schools in America, 500, 32% of 500 and 68% of 500 are definitely going to be higher numbers than 10. So we're fine there. And then 500 people, or 500 students, is definitely less than 10% of all of the nation's students. Is 500 less than 10% of Cherry Creek's population? It is. It could be. So 500 would mean we'd have to have 5,000 here. So we have less. We have 3,600. So 10% of 3,600 is 360. So independence doesn't match here if we talk about this school. But if we talk about all the high schools in America, that might. So it depends, and it becomes important on your wording of your problem. What is the probability that more than 175 students prefer to end the semester before winter break? I think we could do that. And again, what I'm having trouble on this problem is it doesn't look like it's going to face up with independence because the wording, they're skimping on some of the wording. But let's see if we do letter B. I'm going to do NCDF. I'm going to go 175 out of 500. And then I'm going to go, well, let's talk about 10,000 people. That could be, even though that's still not all of everybody. We have 0.32 as the mean. And then we have a 0.32 chance of it happening times a 0.68 chance of it not happening. And we're going to divide that by 500. And again, everything's under the radical there. I don't have an answer for that. But if you were to work that out, I bet you would find something. And then what is the probability that fewer? So more than, this one is the more than. And the reason this is more than is because I'm going this way on the curve, where I'm taking out the 10,000 this way. The other one being less than, we are going to be looking at this. And so I'm going to do the NCDF. And I would have this way like a negative 1,000. And then I would go 158 over 500. And then the 0.32. And then the 0.32 times the 0.68 over the 500. And then that would give you that answer. And again, I didn't work that one out. I apologize. So, does everyone feel okay with when you're using the NCDF, I don't have to use the Z table at the back of the book and go 1 minus to get to the right, because this would find the area to the right because lower bound, upper bound, and this finds the area to the left because it's lower bound, upper bound. That's what we're looking for. Company claims that 5% of its product will be defective. We've talked about this before. We talked about airbags in one of these cases. A simple random sample of 300 products contains 10 defective products. Do the 3 assumptions apply? Well, it says a simple random sample. We're just looking at the products of this factory, so it does look like it's random. 5% is 0.05, so if I go 300 times 0.05, I get 15, so that's bigger than 10. And then if I go 300 times 0.95, I'm going to get, I think, 285. So that's going to tell us it's normal. Is it independent? Is 300 less than 10% of its production. And it depends, I guess, what the company is, but let's just claim that we're talking about plastic cups. Is a company going to have more than 300 plastic cups that they make in a year? I think so. I think it could be independent very easily because 300 would be less than 10% of its entire population. And then it says, what is the probability that 10 or more defective products, so 10 or more, you're talking about to the right. So if you do the NCDF, we have 10 out of 300. That's our picked out. And then we can say, okay, let's take this up to 1,000 or 10,000. And then 0.05, that's what we say that our average would be. And we're going to 0.05 times 0.95 all over the 300. And if you do that math, you're going to probably find that could happen. Number 6, manufacturer of cold medicine claims that 62% of adults will suffer from at least one cold during the winter. A sample of 200 adults is questioned. Is it random? Sure doesn't say it. Some of you are laying down and sleeping. I'm sorry for you. 200 adults, a sample of 200 adults is questioned. Random or not? It didn't say it, so you have to question if it's random. Then when they sit there at the Walgreens for a week saying, hey, did you get a cold? No. Hey, did you get a cold? So I don't know if it was a random sample. Normal distribution, if you were talking about a random sample of 200 times 62, or 0.62 is 124. 200 times 0.38 is 76. So it's going to fall into that category of normal. If it's independent, is 200 less than 10% of the entire population? And I'd say yes. And again, it was weak on telling us what they were talking about as far as the problem goes. And then probability simple, if you go in, it's pretty easy, NCDF of 0.65. You go all the way up to 10,000 or whatever. 0.62 is your probability that they would get the cold. And then 0.38 not, over 200. And that's about all I got. I know there's number 7, but I don't feel like doing too much more. Guys and girls, let's have you guys start working on worksheet 6.3. It's starting your review. We'll work on that today. And then we'll do another one next time.
Wait, so when you get 0, does that mean you did it wrong, or is it that the answer?
Let me see your calculator. Let me come over and take a look. Let me start saving this real quick, and I'll be right back.